Business calculus students, good work making it this far into the videos. We're on the last page of our final review worksheet. We're going to be talking about definite integrals. Problem 25 says approximate the area under the graph of f of x equals x squared, negative x squared plus 13 over the interval from negative 2 to 2 using 4 rectangles with left endpoints on the curve. All right, this is a pretty detailed problem. So the first thing I want to do is to construct, at least approximately, the graph of negative x squared plus 13. Notice this is a parabola that opens down. We know it opens down because of that negative leading coefficient, and it's been translated up the y-axis by 13 units. So I'm going to construct a parabola opening down with y-intercept 13, again, approximate, between negative 2 and 2. So here's my function. And x equals negative 2, x equals positive 2, somewhere along here. Okay, so a pretty rough sketch here. Now, between negative 2 and 2, I have 4 subintervals, and I'm going to be using 4 rectangles. So the width of each of these rectangles should be 1. So I'm going to start over here on the interval between negative 2 and negative 1. That's going to span the base of my rectangle. I'm going to put the left endpoint on the curve. That defines the height of the rectangle. So to approximate the area between the curve and the x-axis on this interval, I'm going to find the area of that rectangle. For the second interval, spanning negative 1 to 0, I'm going to do the same thing. I'm going to put the left endpoint on the parabola. That defines the height of my rectangle. I'll calculate the area of that rectangle to approximate area between the curve and the x-axis. I continue this process until I have my 4 rectangles. My scale wasn't exactly perfect there. So the area of each rectangle added together is going to approximate the area between this parabola and the x-axis from negative 2 to 2. Okay, so the area of each rectangle is calculated as base times height. In each case, the base of those rectangles has a length of 1. So the area is going to be approximately equal to, working on rectangle 1. The base is 1. The height, well, to figure out the height, I need the function value here. The function value is f of negative 2. Okay, so that's my first rectangle's area. Let's find the second rectangle's area. Again, its base is 1. Its height is whatever the function value is right here, right? We can calculate that as f of negative 1. Hopefully you get the process. Each rectangle has a base of 1, and the height is given by the function value at the left endpoint. So here I need f of 0, and then finally base 1, height f of 1. All right, so that's the plan. Let's calculate each of these. Since all of those ones don't change the function values, I'm going to ignore them. So let's evaluate f of negative 2. If I plug negative 2 in for x and square it, I get positive 4, but this additional negative makes it negative 4, right? And negative 4 plus 13 gives me 9. So the area of my first rectangle is 9 square units. The area of my second one is evaluated by f of negative 1. So again, I have negative times negative 1 squared. That gives me negative 1 plus 13 which is 12. So the area of my second rectangle is 12. Plugging 0 into our function next, we end up with negative 0 squared plus 13, or 13. So the area of this rectangle is 13. And finally, f of 1, if I plug that into my function, I would see that it's 12. So the area of this rectangle is 12. Now I simply sum those values to determine the approximate area. Let's see, 10, 20, 30, looks like we're going to end up with 46 square units, approximately. Okay? All right, moving on to definite integrals. Instead of approximating area, now we're going to find the exact area. The exact area between the curve and the x-axis. Notice the limits here are what make this a definite integral. So the first thing I'm going to do is integrate term by term using my reverse power rule. I'm going to put this in a set of brackets. So I have the integral of the term 2x. We take our constant multiple through to the antiderivative. We add 1 to the exponent and divide by that same number. Okay? Then we integrate our second term. The second term is the constant 4. Its antiderivative is 4x. In this case, since it's a definite integral, I will not need that arbitrary constant c. You can leave it off every time. So the antiderivative here we're going to be working with is x squared plus 4x. Now, because it was a definite integral, I'm going to evaluate this from 3 to 5. So the way this is accomplished is by plugging in first our upper limit for x. So I'm taking my antiderivative, evaluating it at the upper limit, and then I'm going to subtract this same antiderivative evaluated at the lower limit. Upper limit minus lower limit. So in this first set of brackets, we have 25 plus 20, which is 45. In the second set of brackets, we have 9 plus 12. We're subtracting this. What does that give me? 21. And then 45 minus 21 gives me 24. All right? Now, you want to see something awesome? You can check this with your calculator. If you will go to y equals on your calculator and type in the original integrand, which in this case was 2x plus 4, and go to your calculate menu, second calculate, look at option number 7. That is an integral, right? You know what? I'm spotting over here. I have a little bit of an issue. Let me correct my viewing window before we calculate this integral. Okay, let me do zoom. Maybe it'll let me quit out of here first. Okay, so there's my y equals. You may be on the same viewing window. Zoom 6, zoom standard. Okay, that way I can see x equals 3 and x equals 5. Start the process over. Second, calculate. Number 7, integral. The lower limit is 3. Enter. The upper limit is 5. Enter. This is calculating the exact area between the curve and the x-axis. And notice this, it tells us 24. Isn't that awesome? See, so you are rewarded for working through these videos. You can check your work using your calculator on the final exam before I check it. That is awesome. On 27, this one gets a little more challenging because we have to do our substitution process. Notice I can't just distribute the x cubed here because I have an exponent right here. So what I'm going to do is make a substitution. Let's let u be the inside of our composed function here. U is going to be 1 plus x to the 4th. So this part will be expressed as u to the 3rd power. As always, let's differentiate both sides of our substitution statement. And we're looking at leftovers. The leftovers in the integral are x cubed dx. I want to make sure the right side here looks exactly like the leftovers. So I'm simply going to divide both sides by 4, or think of it as multiplying both sides by 1/4. So that x cubed dx in the problem will be replaced with 1/4 du. So x cubed dx, which we see right here, is equivalent to 1/4 du. So rewriting our integral in terms of u, we have u cubed times 1/4 du. All right, now we have gone from variable x to variable u. We've made this significant change. My original limits are x values, okay? So what I need to do is update these to be u values. When x is equal to 0, remember the relationship between u and x is given right here. U would be 1 plus 0 to the 4th, or u would be 1. So my previous lower limit, x equals 0, is now my lower limit, u equals 1. Let's do the same thing for the upper limit. When x equals 1, u is 1 plus 1 to the 4th, or u is 2. So my new upper limit is 2. Let's integrate. We can take this coefficient 1/4 to the left. We can integrate u by adding 1 to the exponent and dividing by the same thing. Remember, we do not need a plus c on a definite integral, and we'll evaluate from 1 to 2. Notice that 4 times 4 in the denominator there is 16, and we'll plug in our upper limit minus lower limit into our antiderivative. Let's see, 2, 4, 8, 16 over 16 gives me 1 minus 1/16. I'm going to think 16 over 16 minus 1 over 16. We end up with 15 over 16. Don't forget, you can check all of your definite integrals on your calculator. So let me remind you of this process. Go to y equals, clear the function that you have there currently, and type in the integrand, x to the 3rd times the quantity 1 plus x to the 4th raised to the 3rd power. Let's look at it in the standard viewing window, zoom 6. And if you want to zoom in a little bit, that might help on this problem so you can see what we're calculating. So I'm going to do zoom number 2, zoom in. I'm going to press enter, and I'll be able to see a little more detail of the curve. Second, calculate. One more time. Sorry guys, I have a frozen calculator. Hang on just a sec. Okay, here we go. Second, calculate. Graph. There we go. Had a stubborn calculator there. Second, calculate. Number 7, lower limit 0, upper limit 1. Enter. It's going to give us the numerical approximation, 0.9375. Notice it shades the area represented by the definite integral. Let's compare our decimal approximation with the calculator's result. And we end up with exactly the same thing. So we are in good shape. Again, if you check your work before I do, that is always a good thing. All right, finally, our last problem, number 28. Remember, there's only 20 problems on the final exam. A small company of science writers found that its rate of profit in thousands of dollars after T years of operation is given by the function P prime of T. Find the total profit in the first 3 years. So what we have is the rate of change. Notice it's the derivative. but we're just looking for the total profit function. So how do I get from derivative back to original? I have to integrate. So my total profit function is going to be the integral of p prime of t with respect to the variable t. This is the integral of 9t plus 9 times t squared plus 2t plus 2 raised to the 1/3 with respect to t. Again, because I have a composition, I have a function of t raised to a power, I'm going to have to make a substitution. Let's let u be the inside part of that composition so that the derivative du is 2t plus 2 dt. So this part of my integral is going to become u to the 1/3, and my leftovers are 9t plus 9 dt. I have in my leftovers over here 2t plus 2. So this is going to be sneaky. Are you ready for this? Let's factor out a 2. That leaves behind t plus 1. Divide both sides by 2, or think about multiplying by a half. Now to make this right side look like the leftovers, I can simply multiply by 9. But what I do to one side, I have to do to the other. So we end up with 9 halves du equals distributing 9t plus 9 dt. So this now looks like the leftovers. The leftovers in the original integral, underlined there in green, will be replaced with 9 halves du. So we end up with the integral of u to the 1/3 times 9 halves du. Let's go ahead and integrate. So we have 9 halves times the antiderivative here. We need to add 1 or add 3/3 to the exponent and divide by that same number. Okay? Now I'm going to leave off the plus c because we are about to turn this into a definite integral. So hang on for just a minute. Now, under the u, we're dividing by a fraction. That's the same thing as multiplying by its reciprocal. So we can clean this up a bit. We end up with 27 over 8 u to the 4/3. And remember, u is the same thing as this. So my total profit function, running out of room, I'll write it over here, replacing that u with t is t squared plus 2t plus 2 to the 4/3. Okay? Find the total profit in the first 3 years. So ultimately, I need to evaluate this from 0 to 3. Okay, so we've integrated. Now we're doing the definite integral part. We're going to evaluate p of 3 minus p of 0. Is everybody with me? If so, I'm going to clear up a little space right here so I can work this part out. Plugging 3 into our newly found profit function. And subtracting profit evaluated at 0. So 0. You didn't think I'd let you end up with an easy one, right? The very last problem. Let's evaluate with our calculator. So we have 27 over 8 times, first we plug in 3. 3 squared plus 2 times 3 plus 2. Uh-oh. Going too fast, not paying attention. All right, back to scratch here. 27 over 8 times 3 squared plus 2 times 3. There we go. Plus 2 raised to the 4/3 minus 27 over 8. Notice 0 squared plus 2 times 0 is 0. So that just leaves a 2 there, raised to the 4/3. 139.02. Now don't forget the original problem said the profit was measured in thousands of dollars. So if I multiply this by 1,000, I need to move the decimal 3 places to the right. Okay, so $139,022, and if you want to go all the way out to 81 cents, sounds good to me. So we end up with a total profit, $139,022.81. All right, congratulations making it through the final exam review worksheet, almost all the way through the class. Best of luck to you on your final exam. I hope you do very, very well. Thanks for your enrollment in the class, and thanks for your hard work this semester.